Hello everyone. So now we are going to look the different types of BGP and we are going to perform the lab. So we have two types of BGP. We have two flavor of BGP, internal BGP, external BGP. So first we will look the internal. Internal BGP, if the peer are in the same AS, if peer are in the same AS, then it is known as internal BGP, IBGP. In the shortcut we are calling IBGP. In simple, when we are configuring both the site AS number is same, then we call that one as a IBGP. Example, I have one router here, R1. I have another router R2. I connected like this. Here also I am configuring with the AS1. Here also AS1. Then this will come under category of IBGP. So this point we need to remember. And here, when we are configuring the IBGP, we will have the TTL value will be 255. Time to leave. We use this value to avoid the loop. If you remember, in the switch, we have the STP, RSTP to remove the loop from the network. But in the router, we have this technique like when the packet is going through the router, n number of router, after they reach to this number of router, packet automatically is going to destroy. So this one we need to remember. In IBGP, TTL value will be 255 and AD value will be 200. And for IBGP, no need to connect directly. No need to have the direct neighbor connection. So now we will look how we can configure this one. So here I taken one router, AS1, I am using both are using same AS. Autonomous system I am using both same. Both are same means internal. Both are different means external. Like this we can remember. Here I am using the IP schema 192.168.12.0, that is 12.1 this side, 12.2 this side. Here loopback 0 1.1.8, here loopback 2 or loopback 0 I can use 2.2.2. This just assigning the IP address from here to here will be normal common what we done from the starting. Both the side we will assign the IP. This is a special configuration here. The new thing we are going to learn here. So what we need to do, we need to first write router BGP and then here we need to write the AS number. What we will write? Router BGP AS number. As we are saying AS is 1, both the side. Both router is having same AS, so we will write here 1. After that we need to define neighbor. If you remember, before we are not defining the neighbor. Neighbor is discovering automatically in the OSPF in EIGRP. But now in BGP we need to set up manually. They will not detect automatically. We need to configure manually. So what we will do, we need to write neighbor and whatever the neighbor IP, and then we need to write remote AS and give the neighbor AS number. Let me repeat again. I am saying if I want to configure any routing protocol, how I can configure? I will write router OSPF, router EIGRP. If you remember what we are doing, we are writing router EIGRP, router OSPF. We are doing like this. Or let me write here. If I want to configure, I have one router here. This is a R1. I have another router. This is a R2. I connected this both router. I am using here this side will be the IP will be 192.168.12.1 and this side I am using 192.168.12.2 and here I have one loopback example 1.1.1.1. Here I am using another loopback 2.2.2.2. Now I want to configure BGP. So how we are writing? We can write router BGP. As we are doing same thing for OSPF also, router OSPF 1, that is process ID we are writing. Here is AS number. So router BGP AS number we need to write. So if you see AS is equal to 1, because it is not necessary we should have 1. We can have 2, we can have 100, we can have 200, but both should be same. Because we are doing IBGP, internal BGP. So IBGP, we are doing IBGP. So what we can say? IBGP is nothing but internal BGP. So here I can use same AS. This router should have same AS, this router should have same AS. Example, I am using 2. So what I will do here, I need to put here the AS. So I will write AS is 2. So I will write router BGP 2, and after that we need to do manually neighbor. We need to tell to BGP who is our neighbor manually. So we need to write this command. We are going to write, we are writing neighbor, and we need to write the neighbor IP. This is my neighbor. Okay, I am here. This is my neighbor. So I will write 192.168.12.2. After that I need to write remote AS. What is the remote? Remote means this one. I am here. Remote is nothing but neighbor only. So what is neighbor AS? 2. So we will write 2 here. So this is the configuration. And now I have this route. This is connected to me directly. I need to advertise this. So how I will advertise? Same as we do before. We will write network and the network ID. Example, if this is a /8, then 1.0.0.0. In OSPF we are writing wildcard mask, but here we will write the subnet mask. But we need to write mask, and then we need to write whatever the subnet mask, like this. This is the configuration for R1. For R2, what we will do? R2 also same configuration. We will write router BGP, and then AS is 2, so this will be same, and neighbor is this one. This is my neighbor, so I will write 192.168. This will change for the R2 192.168.12.1. This one will come there, and remote this AS. So this AS and both are having same AS. So here is 2 and here is also 2. And then I need to advertise my network. This is my network. So this will go and this will come 2.0.0.0, and mask will remain same because it is 8. So this way we can configure. This is a new steps we observe here. Before we did not done manually this one. Now we are doing manually. This is a command we need to remember. Manually we are configuring. And this is normal as we define network ID, then we will write the wildcard mask. But here we need to write mask and we need to define that one. This is the BGP steps. This is the IBGP. This way we can configure the IBGP. So now let's do lab. So we will have the idea about this one. So what I will do, I hope the steps you understand already. Now let me go to GNS3 or EVNG. I have 2 router. Okay, let me show you which images I am using. I am using this one. All images is okay, no problem, it is working, but anyhow I will put this here. So in case if you face any issue, try to use this image so it will work. So now I taken normally 2 router, just I drag from here, same as we done before. And I connected, I am using fast Ethernet 0x0 both the side. I will start this router, and after that I will take console of this one and also console of the R2. Both console I taken. Now we can write the configuration. So what I will do, I will use the notepad to write the configuration. It is simple as we use before that one. Let me define the IP schema. Here we are going to use 192.168.12.0/24. This one here, I will make this duplicate. Here I will have the loopback. Here I will use loopback 0, and IP I will give 1.1.1.1/8, and I will make this duplicate here. I will keep this here, and here I will use, let me write here 2.2. You can use any IP. I am using the, what I can say, I am using this IP. And here we can write, this side will be .1 and the other side will be .2 here, this side .2. So now everything is good. We have the IP schema, so we can start writing in the notepad. So I have my notepad here. I can start. What I can give the name, this is a IBGP basic lab. Okay, so here R1 configuration, we will same thing as we do before, enable config t, then host name. What is the host name? We can give R1, then we can assign the IP interface, pass Ethernet 0x0, IP address 192.168.12.1, 255.255.255.0, then we write no shut, and then interface loopback 0, and then I will assign the IP address to loopback 1.1.1.1, 255.0.0.0, and now is the BGP. So BGP, how we will configure? Router, then we will write BGP and AS. Here let me write the AS, we did not write AS, so here we will use the AS is equal to 1. I will make duplicate here. Same here also, we are, because we are doing IBGP, so both sides should be same AS. So what I will do here, I will put router BGP 1. Then I need to define neighbor, or if you want to first advertise this one, you're connected, you can write that one, no problem. Example, I want to advertise my directly connected, so I will write network 1.0.0.0, and after that I need to write the mask, and what is the subnet mask? 255.0.0. I need to write network and network ID, and then mask and subnet mask of this one, whoever is directly connected to me, whatever the network I want to advertise in my side. After that I need to define the neighbor. This is my neighbor IP. So how we will define neighbor? To define the neighbor, we need to write neighbor. Okay, we need to write neighbor and give the neighbor IP. This is the neighbor IP 192.168.12.2, and then after neighbor IP we will write remote, because it is remotely connected to us, remote AS. And what is the AS? Here is AS is 1, so we will write 1. Okay, this is only the configuration, that's all. After that I will copy this whole thing, I will divide this page, I will paste here, and I will modify here. I will write here 2, this will be 2 here, and after that IP will be this 2, and this will be 2.2.2, 2.2.2.2, and here this will be 2. AS is 1 both the side, here also 1, here also 1, and remote, this is our network. Here I am, here I want to advertise this one, so I am advertising that one in BGP, and I am connecting to my neighbor. So this is my neighbor IP is 12.1, this neighbor IP is 12.1, this is my neighbor, so neighbor is 12.1, and remote AS for the neighbor is 1. So this is only the configuration. This is only the configuration. So now we can copy and paste. This is a BGP configuration, IBGP. So I will go to R1. This is a R1. Just I will paste here. Okay, I paste here. And after that, what I will do, I will take this from here to here, and I will paste this in the R2. So I will go in the R2. Let me make this big. And I will paste in the R2. So we pasted in the R1 and R2. Same like in the OSPF we have the 3 table. Here also we are having the 3 table. We can check the routing table, we can check the neighbor table, and if you see BGP come up here. Okay, so now we have the neighbor, so it come up. Now we can check show IP root and enter. Still we did not get root, it will take some time, and I can check show IP root BGP. Still we did not get the root, it will take some time. BGP is a slow protocol, it will take time. And meanwhile we can check the other thing. Example, I will write show IP root, still we did not get root. Here we will have the B. If you see here like this, we will have B should come here when we check the routing table. I am writing show IP root, and after that I can write BGP, so it will show us BGP if it is available. Here nothing is there, so it will take some time. Show IP root, if I write show IP root, now if you see, now I have the BGP, this one. So I am in the R2. R2 is learning. R2 is learning. What R2 is learning? I am here. R2 is learning 1.1.1. This one from where? From the BGP. This is a B. B means BGP. And if you remember, I told AD, that is administrative distance, will be 200. If we configure IBGP, we will have the AD value will be 200. If we configure the EBGP, we will have the AD value will be 20. So this is correct. Now let me show you here again. I will write show IP route and I will write BGP. And if you see, I have the route of BGP, that is I am here in the R1, I am getting this route and this is the AD value. If I want to go, I can go to this. If I want to reach here, and this is the time, from what time this route come in our routing table. Okay, so we can write show IP route like this, show IP route. So we will get that detail here. So this is the routing table. How we will check the routing table? We can check by writing the show IP route. So what we observe here? We have B. B is nothing but BGP and the AD value is the 200. We verify this one. Now I want to check the neighbor. So how we will check the neighbor? We will write here. Let me write here. Show IP BGP neighbors. If I write this one, I can check the neighbor, and also we have one more commands also I will show you. This is a BGP version 4 is using, and the remote router ID is 222 for the remote. Remote means our neighbor. This one, this router is having the router ID 222 and we are using the AS1, remote AS is AS1. And here also we are having the timer. We are going to discuss timer after some time. Yeah, keep alive. Like hello, we are sending the hello packets in the OSPF. Here we have the keep alive. Keep alive interval is a 60 second. Hold on time is 80 second. Later we are going to see this all. And here how many we send hello, that will show here. How many packets we send. Here also we are having the messages. Same like in the OSPF we have. So we can check that detail. I will show first of all the basic thing. Like let me show you TTL value also. Here we can get the TTL value also. Here let me check. We will have TTL value will be this one. If you remember, I told TTL value will be 255. When we configure the IBGP, TTL value will be 255. So we have the 255 as a TTL value. And port number we are using is 179. So now let me type the other command, like if I want to check the show IP BGP summary. With this one I can get the neighbor table. So if I write show IP BGP summary, in this one what we are getting? We are getting this is a BGP router identifier. I am here in the R1. So he is saying me BGP router identifier. So that identifier is nothing but router ID. For R1, router ID is 1.1.1. If you remember, in OSPF what we are calling? In the OSPF or any other routing protocol, we are saying first they will check the loopback, any logical address. If we have more than one, they will select the highest IP. If we don't have the loopback, if we don't have the logical, then they will take the physical. So same thing here also. In the BGP also, they are going to select the router ID. They will communicate through router ID only. Router ID is like a name of the router. So how they will select router ID? They will first check the loopback, that is logical interface. If we have any virtual interface, they will check and they will take that IP. If we have more than one, they will check which one is big, that one they will take. But now here we have only one, so they are going to take that one only. And local AS number. Local AS number means this guy AS. AS is having 1. So that is the AS1. And this is a BGP table version 3. This is a BGP table version 3. And the main routing table version 3. So this is going to update. Example, if I make any changes, we will have this number increment. So like a version number, like if I change anything, this table will increment. This table will change. So when this table change, this number will change. Example, this is 3 and this both are same only. What I will do? I will go here. I will go to the interface loopback 0, okay, and I will make shut. This interface I make 0, okay. Shut means this interface go down. So we have this root will remove from the BGP table. So this value will change, 3 will change to 4. Now let's see. If you see this 3 change to 4. Before what we have, let me big. If you see before what we have, before we have 3. This BGP table version, this is like a version 1. If we make any changes, it will change to 2. If we make again changes, it will make to 3. If we make again changes, it will make to 4. If you see, now it changed to 4. If you see this one, this both are same, BGP table version and main routing table version, both are same only. Whenever we make modification, it will increment. Now what I will do, I will write no shut, and then again this value will change. Now we have the 4 here. Now you will see, you will have the 5 here. If you see, we have the 5 here, okay. And here they are giving, we have the 2 network entry, this much memory he is using to store in that table. So no need to worry about this memory. The main important thing is here, this is my neighbor IP, this is my neighbor IP address, neighbor ID here. Let me show you. I am here in the R1, so this is my neighbor. So neighbor is 192.168.12.2. So this is my neighbor, and this is a version. This version and this one is different. This is a BGP table version or main routing table version. This is a IP version. I am using IPv4, that's why it is a 4. I will use IPv6, then it will be 6. And then here this is a AS. AS means AS number. We are using AS1, and the message receive, how many message they receive? 13. And how many message they send? 12. We have here message type. Later we are going to discuss the message also in detail. And the table version is 5. This version, table version, and this one both are same. This one. If you see here, table version 5, main routing table version 5, these both are same. And if any traffic is in queue or outgoing queue, it will appear here. Now nothing is in the queue, so it is not showing. And if anything happen like route go down or up, from what time it is there, that will show us the time. If anything go wrong here, like from what time this neighborship is there, that time will be here. If it go down, it will change the time. And now this is a state. We have the states here. If you remember, in the OSPF also we are saying we have the 7 state, init, dawn, like this. Here also we are having some state, so that state will appear here. And this is a prefix, so I am receiving only one route from here. If you see how many routes I am getting, only this one, so that's why it is 1. If I add one more route here, it will change to 2. So this is a neighbor table, okay. This is a neighbor table. What we learn here in the neighbor table, we have the neighbor ID, this is the neighbor IP, version, AS number, and the message type, all this one, and BGP router identifier, that is nothing but IP, that is a router ID only, and the AS number and the version of the routing table. Now we will see other table. We check show IP BGP summary. Now I will check show IP BGP. When we write show IP BGP, we will get here example. If you see here also same thing, this is a BGP table version 5, and this is a local router ID. Here they are saying router ID, here they are saying identifier, both are same. So here it is showing the 1.1.1, here it is showing also same thing, router ID. After that we have the state code, some codes we have, this one we are going to see, and also we have origin code, IBGP or EBGP or incomplete. Later we are going to see this all. Now what we can say, this is our network, whatever network we are learning. I am here in the R2. If you see, I am here in the R1, and I am getting the route this one, okay. I am getting this one also. I am learning 2 route, and if you see this star and the greater than symbol, what is the meaning of this one? Star means valid, this is a valid route, and greater than means this is a best route. Example, I am getting 2 route. If I am getting 2 time 1.0.0.0 from 2 different location, So one time they will write star greater than, and one time they will write only star. So we can say star means only valid, and star and greater than means this is valid route as well as this is a best route. So now I am getting only one route, so they will say this is only the valid and this is only the best, because now we have only one. Later when we are going to do more and more lab, you will understand sometime we will have the star but not the greater symbol. And sometimes some example what I want to say, same thing will be written like this only, but we will have star 1.0.0.0. So we can say this is a valid route but not a best route. This is a valid as well as best route. So we can see here star means valid and greater than means best. And after that, this is a network. If I want to go to this one, I can go through this next hop. So 00 means it is connected to me. I am R1. I am checking here. If I want to go, this is a destination. Okay, this is a destination network. If I want to go to this network, how I can go? This is connected to myself. 000 means 0.0.0 means ourselves, same router. So by seeing this one, I can say R1 itself is having this route, because this is loopback of the R1, and metric is 0, local preference is 0, weight is 3276, path is I. This one is a attribute. This one we are going to discuss later when we have the good command in the BGP. When we learn lot of things, at last we are going to learn the BGP attribute, how we can manipulate. We can manipulate the traffic by using this attribute. This attribute play a major role. So later we are going to learn this one. And if you see here, this is I is nothing but IBGP. We configure IBGP. And now what I am saying, this is the network. I need to go to destination. This is my destination. So if I want to go to this one, means it is connected to me directly. 0.0.0 means it is connected to me directly. I am in the R1, so this is connected to R1 directly. And if you see 2.0.0, this is not connected to me. This is the, if I want to go to this destination, I need to go here, this point. Okay, and here local preference is 100. Why this is 100, why this is 0, we are going to discuss in the coming labs, that one. So this is another table. So let me check what else I have here. So this one we check show IP route. Here we can check, and this one also we check already. TTL value also. And this is this one I can capture, I can show you. This messages already passed, because before we are configuring, that time we need to capture this one. Anyhow, in the coming labs we can capture and we can check this one. Let me check here. I will write the BGP here. So it will capture the BGP message, BGP, and I will select this one. If you see in the BGP, this one 192.168.12.1 is sending to 12.2. As we told, BGP messages is unicast, not the multicast. Unicast means 1 to 1. 12.1 is sending to 12.2. 12.2 is sending to 12.1. What they are doing? Keep alive, keep alive. There is a messages keep alive. And also they are going to establish the TCP. TCP is using three-way handshake. If you remember, we have the TCP. TCP is a protocol which is going to form the three-way handshake. So when we connect the two router, example I use one router here R1, and I connected the R2 here, and when we configure, this guy is going to send the sync packet, and this guy is going to reply sync acknowledgement, and this guy is going to reply the acknowledgement. Then they will have the session start. They will start the TCP session. After that they will start the sending of data. So here they are sending the sync ACK. This guy is sending sync message to this guy. So later we are going to see that one all. So now what we learn here? We learn here how to configure IBGP. And if we see here, what else I wrote here? Okay, after that we have the IBGP. So let me stop this recording. This one is for IBGP.